Guys, this is a really quick recap video on what we did in class today. So I gave you a few definitions. We talked about what an atom is, and there's many definitions in different books, but essentially, and it's the basic form of matter, the nucleus has protons, which are positive. There are also neutrons in the nucleus. The neutrons are neutral, and the electrons are in the electron cloud on the outside. When we go down here, we can look at a Bohr model of the atom. Now, I drew this on the board for all of the classes, and I just made one model here. Magnesium has a atomic number of 12. Therefore, it has 12 protons. Now, the neutral atom of magnesium also has 12, count them, electrons. There are 2 electrons in the outermost shell, and we call those valence electrons. Electrons in the outermost shell of an atom. Now, magnesium is a metal. And if I take these electrons away from magnesium, it loses its outermost electron. So the shell can go away. Now it becomes magnesium 2 plus. It becomes an ion. It becomes a cation to be specific, which it means that it is positive. And it is when an ion is when the protons are not equal to the electrons. So it is now a charged atom. It can be either negative or positive. If it is negative, then it is called an anion. But if it is positive, it is called a cation. So metals become cations, and nonmetals will become anions. Okay? And you can see the definition now up here, if I scroll up, of a metal and a nonmetal. Nonmetals are over here on the right. You can see nonmetals, there's blue ones. And metals are over here, many categories of metals. See all these metals? Over here on the left. Nonmetals, they can be hard, soft, that doesn't matter. The definition I'm going to give to you is it's a type of element that is more likely to gain an electron in a chemical reaction because it has high electronegativity. And a metal is a type of element that is more likely to lose an electron in a chemical reaction because it has low ionization energy. So let's get into these two definitions, electronegativity and ionization energy. Ionization energy is the amount of energy needed to pull an electron off of a neutral atom in the gaseous state. So let's scroll down here and look at ionization energy. You can see the element with the highest ionization energy is helium, and the element with the lowest ionization energy is cesium. Well, actually, you know what? It's actually francium, but they didn't put francium on this chart. It's even lower than cesium. Because cesium and francium are metals. Helium is a nonmetal. So metals will have low ionization energy. Okay? That's why they will lose electrons. They have a low amount of energy required to pull off their electrons. Nonmetals, as you can see, have high ionization energy. And I will explain to you why this goes down later. It has to do with something called the shielding effect. We'll deal with that later. Electronegativity is a value associated with how much an element wants to take an electron away from another element, excuse me. How much, it's the value associated with how much an element wants to take an electron away from another element. So here is electronegativity chart. The most electronegative element is francium, and the most is fluorine. And the least is francium, because fluorine is a nonmetal. Therefore, it has high electronegativity. Francium is a metal. You can see the metals have low electronegativity. All right, so take these definitions, fill out the chart. We will go into this in more detail later.